Form 1 Chemistry. Today we focus on lesson 5 and we are going to look at a new topic, and the topic of the day is simple classification of substances. And today we are focusing on separation of mixtures as our key subject of the day. Now, before we begin, I'm your teacher Benjamin K. Makanda. Let's look at the specific objectives of the lesson. Now, in this lesson, we are supposed to meet the following objectives. The first objective is that by the end of the lesson, the learner should be able to carry out simple experiments to obtain pure substances from mixtures. So this is our main objective that we have to achieve at the end of the lesson. So we should be able to carry out a simple experiment that can help us separate substances from the individual mixtures. Now, what's the order of our lesson? Our lesson is going to be in this order, that is lesson preview. We want to review lesson 4, and in lesson 4, we were at the introduction to chemistry. That was the first topic that we did. We introduced ourselves to chemistry and looked at the various apparatus that are used in the chemistry laboratory and how those apparatus can be used. We also looked at sources of heat in the lab. And then we ended our discussion in the first topic by looking at some of the laboratory safety rules, what you're supposed to do while in the laboratory. Now, given that we understand that now, we now want to use that knowledge to help us now work in the laboratory, because in this topic is practical and we will need those rules to guide us in all the activities that we're going to undertake in the laboratory. So that is generally the review of lesson number 4. Then, the other thing that we have to note now in this lesson that we are just about to begin is that we should be able to carry out simple experiments to obtain pure substances from mixtures, after which, from our discussion, we'll be able to attempt questions, and that means we'll have an assignment for the day. So that is how we are going to carry on with this lesson. Look at the review of lesson 4, which you have already done. Carry out a simple experiment to obtain pure substances from mixtures, and then lastly, look at the assignment as part of what we would have discussed in the entire lesson. Now, we want to begin by our lesson, and our lesson will look at the introduction. So, we have to look at the introduction. Now, today we are discussing about simple classification of substances. Now, these substances are obtained from a broad term called matter. We defined matter in Form 1 as, in our first topic, as anything that occupies space and has mass. Anything that has mass and takes up space is called matter. Therefore, the key word that can be used to classify substances in this case is matter. Out of matter, you are able to classify things or substances downward. So, how do we begin here? Matter is classified into two broad categories, namely pure substances and mixtures. So, out of matter, we already know what matter is anything that occupies space and has mass. Now, this matter can be classified into two broad categories, and the categories are pure substances and mixtures. Substances can be pure or they can be made up of different other substances, therefore called mixtures. So, matter is classified into two broad categories, namely pure substances and mixtures. We also need to know this about mixtures. Mixtures can be separated into pure substances by physical methods. This means that if matter is classified into two broad categories as pure substances and mixtures, it therefore means that you can obtain pure substances from mixtures. And then how do you do this? You take mixtures and then you separate it into pure substances by use of physical methods. Therefore, from the definition of mixtures, you will realize that the individual components within a mixture retains their property. They retain their property and therefore they can be separated by physical means. Let me just give an example of a mixture, in this case, a mixture of beans and maize. Now, if you want to separate a mixture of beans and maize, you can decide to pick maize from the mixture to leave beans on their own. So that kind of doing of actual picking maize from beans is a physical act. And therefore you are separating beans from maize by what? Physical means. When you employ physical means, then it means that you are separating mixtures by physical methods. Then, still on introduction to mixtures, the other thing that we have to note about this is that pure substances are further divided into categories as elements and compounds. Now, if we have pure substances, we can classify them as elements and compounds. Similarly, mixtures are also classified into two types, and these are homogeneous mixtures and heterogeneous mixtures. Going back to the first point, pure substances are further divided into categories as elements and compounds, so that we have pure substances, but still you can classify them as elements. We can also classify them as compounds. Now, on mixtures can also be classified into two. They can be either homogeneous mixtures and heterogeneous mixtures. And in our today's discussion, we are focusing on mixtures. So if you have matter, then from matter you move on, you come to pure substances and mixtures. Then on the side of pure substances, you have elements and compounds, and then the other side we have mixtures, which are further divided into homogeneous mixtures and heterogeneous mixtures. It's sort of a flowchart that we just want to look at here. Now, we summarize this discussion or this classification. We have just looked at how these ones can be classified, and therefore the chart that we're just about to see here can help us understand what we mean by that. So still on introduction to simple classification of substances, we now have a summary of how we can be able to classify these substances here. So we have a chart here. This is a flow chart. At the beginning, we have matter, and there are three states of matter. They are solid, liquid, and gas. We're able to see there. Then matter can either be mixtures or pure substances. Mixtures have variable compositions. They have variable compositions because they are made up of other components that make up that mixture. So their composition is variable. Then pure substances have constant composition. They have constant composition. Later on, we shall be discussing what pure substances are, and we'll be able to understand what we mean by having constant composition. Now, looking at the method of separating, physical methods, preparing mixtures, separating individual components, we can actually they have a common thing here. They can actually be connected by a physical method. Then, going back to pure substances, we are saying here we may have pure substances which are either elements, and an example of an element is hydrogen. They can also be compounds, and we have water as a compound. What of mixtures? Mixtures can either be heterogeneous mixtures or homogeneous mixtures. Then homogeneous mixtures in most cases are solutions. Heterogeneous mixtures, they are mechanical mixtures that we're going to see in our discussions. We proceed on, but before we proceed, this is just a summary that can help you to classify substances. You start from matter, then you classify matter into two as either mixtures or pure substances. Move down, then classify them further into elements and compounds for pure substances. Then for the side of mixtures, you classify them as heterogeneous mixtures or homogeneous mixtures. I hope that one is understood. Now we proceed on. Now, separation of mixture. A mixture, now we have a definition, is a physical combination of two or more substances where the substances retain their original identity. That's the definition of a mixture. A physical combination of two or more substances where the substances retain their original identity. Look at this example. Take maize and beans, put them together, then let them mix. Then pick a maize from the mixture, pick a bean from the mixture. Look at it. Has it changed in any way? Of course, the answer will be no. They have not changed because as far as they have been combined together, there are two components or substances that have been combined together. The individual components retain their original identity. A bean remain a bean, a maize remain a maize. That's why we are saying a mixture is a physical combination of two or more substances where the substances retain their original identity. That basically is the definition of a mixture. If you take sand and water and you put sand into water, then because sand is denser than water, it will settle at the bottom and water will be on top. So if you separate them carefully, water will not have changed. Despite the color, water will remain water and sand will remain sand because the identity have been retained. And this is now the qualified definition of what a mixture is. A physical combination of two or more substances where the substances retain the individual identity. Still on mixture, some examples are air, we have milk, various fruits and drinks. So these are some of the examples of mixtures that we have. We have air, and we can define air as a mixture of gases. You see now air is a mixture of gases. Why do we define air as a mixture of gases? because it's made up of other components of gases, which include oxygen, nitrogen, argon, carbon dioxide gas, etc., including dust particles and water vapor. Therefore, air becomes a mixture of gases. Then we have milk. Milk is also a mixture. We have that cream part of milk and the real milk, so that one is a mixture, and various fruit drinks, they're also mixtures. Those ones give us some of the examples of mixtures. Now we proceed on separation of mixture. The most important aspect of the mixture is that it has no definite or constant composition. A mixture will not have definite or constant composition because it is made up of various components, and these components retain the individual identity, and therefore that's why mixtures cannot have a definite or a constant composition, because individual components within a mixture retains the individual property. Other thing that we have to talk about in mixture is that mixture is further classified as either homogeneous or heterogeneous based upon its uniformity. So that if you have a mixture, you can either classify it as homogeneous or heterogeneous based upon its uniformity. Before we go into details of these two, homogeneous mixture, take an example from milk. You take some water and pour into milk and then look at the color. The color of the milk will still be uniform. And because the color is uniform, you cannot be able to see water in milk, then that kind of mixture is what we call homogeneous mixture, because the mixture itself has a uniform composition. So we don't have any distinct layer between the water layer and the water layer because the mixtures are uniform. So we have that uniformity in it. Heterogeneous mixture is a mixture in which we have a distinct layer between one component and another component. An example is water and kerosene or paraffin. When you mix the two, because paraffin is less dense than water, it floats on water, and then they therefore form two layers, and that one becomes an example of a heterogeneous mixture. So now, to further understand the classification of mixture, we can use this flowchart here. Now, this mixture, we have mixture here. So, how do we classify this mixture? So, if the main word is mixture here, then we classify them. The first one here, we have homogeneous mixture. That's what we have. So, from mixture, if you can just have a look at it, we have mixture here, then we have homogeneous mixture. Then, on the other side, if we have homogeneous mixture, then back to our discussion, we can also have heterogeneous mixture. So these are the two classifications of mixtures: homogeneous mixtures and heterogeneous mixtures. So we want to understand what homogeneous mixtures are. Now, what is a homogeneous mixture? A homogeneous mixture is a solution that has a uniform consistent composition throughout. For example, salt solution, after dissolving and mixing it thoroughly with water. So if you take salt and you dissolve it in water and you mix it thoroughly, then you may not be able to see the particles of salt in the mixture. This one becomes a homogeneous mixture because it has a consistency. The composition is uniform. We call these homogeneous mixtures. Then there's something that we have to note about homogeneous mixtures, that not only that, but also the individual components cannot be identified in the mixture. So that the individual components, if it is salt particles, you cannot be able to identify them. You cannot be able to identify them within the mixture because the mixture is uniform, and that is what we call homogeneous mixture. Example. So we have a photo here that can be able to help us understand this. This is an example of a homogeneous mixture. So you can't be able to identify the individual components in this. Let's assume this is milk. In this milk, maybe we have mixed it with water. You can't identify what water is and the particles of milk because the uniform has a uniform consistency or composition. This is what we call homogeneous mixture. What about heterogeneous mixtures? So heterogeneous mixtures does not have uniform composition like homogeneous mixture where the individual components can be identified. For example, a mixture of sand and salt. This one is a heterogeneous mixture because the components do not have a uniform composition, and as a result, you can be able to identify the individual components from the mixture because they are seen. So this is what we call heterogeneous mixture, and we have an example to help us understand this. This is what we have. So these are a mixture, and you can see two layers here, a distinct layer. We have the top layer and the lower layer. So these mixtures, the individual components have retained their property, and yet the components can also be identified from the mixture. So this one becomes our heterogeneous mixture. To help us understand what these mixtures are, we are going to have a simple demonstration in the lab that will help us understand what mixtures are and how we can be able to separate mixtures. So we are just going to have a demonstration in the lab which will help us understand the whole term on separation of mixture. Let's have a look at this.
Hello, I'm Tim.
Hi, I'm Melissa, and I live here in Cyprus. We're having a day off from our dancing school, and we're going to have a lot of fun. Unfortunately, a lot of stuff got mixed up. We need to separate the mixtures. Do you know how we can do this?
Let's find out together, Melissa.
Oh no, I think a storm has flown most of the stuff into the pool. Do you think you can use filtration technique to clean the pool? Filtration is a method to separate a mixture of insoluble solids from liquids using a net or filter paper. Solids stay behind in the filter and the liquid passes through. Soluble solids cannot be separated this way. They become part of the liquid, like when you put a cube of sugar in tea. Can you help me sort out things that can be separated using filter paper?
When mixed with water, could you use a filter to separate these items from the water, or do they dissolve in water? Filter paper. Dissolve in water. Mint leaves. Paint. Flower petals. Shells. Mint leaves. Insoluble. Shells. Insoluble. Flower petals. Insoluble. Paint. Soluble.
You're doing great.
Pebbles. Salt. Sugar. Apple. Apple. Insoluble. Pebbles. Insoluble. Salt. Soluble. Sugar. Soluble.
That's perfect.
Peas. Ice cream. Watermelon. Orange juice. Peas. Insoluble. Ice cream. Insoluble. Watermelon. Insoluble. Orange juice. Soluble.
Excellent.
Lemon seeds. Tea leaves. Glucose. Chocolate milk. Lemon seeds. Insoluble. Tea leaves. Insoluble. Glucose. Soluble. Chocolate milk. Soluble.
That's perfect.
Honey. Flowers. Butter. Cumin seeds. Honey. Soluble. Flowers. Insoluble. Butter. Insoluble. Cumin seeds. Insoluble.
Well done.
Thank you. That makes sense. Today we are planning to have a small party and bake a cake. All the ingredients are here. Can you pick the best method to separate the following mixtures? We can use evaporation, heating the mixture so that liquid evaporates to form steam, leaving the solid behind. Distillation, This is the same as evaporation. The only difference is that we collect the vapors of the liquid so we can keep it. Centrifugation. Some ingredients weigh more than others. We can separate the heavier ingredients by centrifugation.
To separate salt from salt solution we use evaporation, distillation, centrifugation. Evaporation.
Perfect.
To separate components of crude oil we use evaporation, distillation, centrifugation. Distillation.
Perfect.
To separate chalk suspended in water we use evaporation, distillation, centrifugation. Centrifugation.
Perfect.
To separate dirt from tap water we use evaporation, distillation, centrifugation. Distillation.
Great.
To separate butter from milk we use evaporation, distillation, centrifugation. Centrifugation.
Great.
Thank you for helping me to separate soluble solids from liquids. When using sedimentation and decanting, heavier particles settle down at the bottom of the liquid and liquid can be poured off. Let's see which mixtures can be separated by sedimentation and decanting by deciding if the statements are true or false.
Sand can be separated from water by using sedimentation and decanting. True.
You're doing great.
Gravel can be separated from water by using sedimentation and decanting. True.
Perfect.
Flower petals can be separated from water by using sedimentation and decanting. False.
You're doing great.
Mud can be separated from water by using sedimentation and decanting. True.
That's perfect.
Leaflets can be separated from water by using sedimentation and decanting. False.
You're right.
Thanks for your help. We're going to have lunch by the lake. This must be real fun. While we look at the food, let's see what we've learned today. Can you tell me what is the best method to separate the following substances? Please drag the substance to the drop area above the method you should use.
Which method should you use to separate meat pieces in gravy? Sedimentation and decanting. Filtration. Evaporation. Centrifugation. Hand picking. Hand picking.
Great job.
Which method should you use to separate lemon juice and seeds? Filtration.
Great job.
Which method should you use to separate hard carrot pulp from carrot juice? Centrifugation.
You're right.
Which method should you use to separate rice and water? sedimentation and decanting.
You're doing great.
Which method should you use to separate salt in water? Evaporation.
Great.
Thank you. I learned a lot about separating mixtures.
So I think we have now been able to understand how we can employ various methods to separate mixtures. So up to there, I want to leave you with a task that will help you understand the demonstration that we've had and our discussion. So you will have to apply that in answering this question, which is part of your assignment. So that was our demonstration. We have already looked at it. So our assignment for the day: sodium chloride was found to be contaminated with the copper 2 oxide. Describe how a sample of sodium chloride can be separated from the mixture. We have just seen from the foregoing that when you want to separate salt from water, what you have to do. So this is one of the questions that you'll have to apply what you have watched to respond to it. So that one becomes your assignment for the day. And then that marks the end to our lesson. And before we call it a day, if you have any comment, question, or clarification, you can call us. You can call us on the number that is on the screen here, 0726-842-644. You can also use our Facebook page, Elim TV. Also follow us on Twitter at elimtv_KE. That marks the end to our lesson number 5. Until then, I've been your teacher, Benjamin K. Makanda. Stay tuned to Elim TV.